Welcome to Chapter 12 of Class 7 Science, Earth, Moon, and the Sun. In this fascinating chapter, we'll join Rashmika on her cycle to school in Kanyakumari as she wonders about the changing shadows of coconut trees. Why are shadows long in the morning but short in the afternoon? Does the sun move across the sky, or does the earth move? We'll explore these questions and many more as we dive into the amazing relationships between our planet, its natural satellite, and our star. Get ready for a cosmic journey through rotation, revolution, seasons, and eclipses. Let's begin with Earth's rotation. Have you ever ridden a merry-go-round? When you sit on it and it turns, the objects around you appear to move in the opposite direction. If the merry-go-round turns anti-clockwise, objects appear to move clockwise around you. A tree would appear from your left and disappear on your right. Earth behaves exactly like this. Our planet rotates from west to east on its axis, which passes through the north and south poles. This rotation takes about 24 hours to complete. Because we're on this rotating Earth, the sun appears to rise in the east and set in the west. The rotation speed is incredible, about 1670 kilometers per hour at the equator. We can simulate this using a globe and torch experiment. When we mark our location on a globe and rotate it from west to east while shining a torch on it, we can see how our location experiences day when facing the light and night when facing away. This simple experiment demonstrates the fundamental reason for our daily cycle of day and night. Now let's explore the daily celestial show caused by Earth's rotation. In the morning, the sun appears in the east as our location rotates into sunlight. At noon, the sun reaches its highest point in the sky. In the evening, the sun sets in the west as we rotate away from sunlight. But it's not just the sun that appears to move, stars do too. If we observe constellations like the Big Dipper, Saptarishi, and the pole star, Dhruvatara, throughout the night, we'll notice they appear to move around the pole star. The pole star stays almost stationary because Earth's rotation axis points toward it. All other stars appear to circle around it. Ancient Indian astronomers like Aryabhata noticed these patterns over 1500 years ago. In the 5th century CE, Aryabhata calculated Earth's rotation time as 23 hours 56 minutes and 4.1 seconds, remarkably close to our modern value. In 1851, French scientist Léon Foucault gave the first simple demonstration of Earth's rotation using a long pendulum, now called the Foucault pendulum. India has installed one in the new Parliament building, symbolizing the connection between Indian thought and cosmic understanding. Earth has not one but two important motions, rotation and revolution. While rotation is spinning on its axis, revolution is orbiting around the sun. Earth completes one revolution around the sun in 365 days and 6 hours, which is why we have leap years every 4 years to account for the extra time. Earth's orbit is nearly circular, not elliptical as often shown in diagrams. Our planet travels at an incredible speed of about 107,000 kilometers per hour in its orbit. This revolution causes the changing night sky throughout the year. As Earth moves around the sun, our night side faces different directions in space. In June, we see one set of stars. In December, we see a completely different set. Traditional communities like the Bhil and Pawara from the Tapi Valley use these changing star patterns as markers for monsoon arrival. This shows how ancient people connected celestial patterns with earthly cycles long before modern astronomy developed. Now let's explore why we have different seasons. The secret lies in Earth's tilt. Our planet's axis is tilted at 23.5 degrees from vertical, and this tilt remains constant as we orbit the Sun. In June, the northern hemisphere tilts toward the Sun, receiving more direct sunlight and longer days, creating summer. In December, the northern hemisphere tilts away from the Sun, receiving slanted sunlight and shorter days, creating winter. There are common misconceptions about seasons. Some people think we have summer because Earth is closer to the Sun, but actually, Earth is farthest from the Sun in July. Others think Earth's oval orbit causes seasons, but the orbit is nearly circular. The real reason is the tilt of Earth's axis. We have special days called solstices and equinoxes. The summer solstice on June 21st is the longest day in the northern hemisphere, while the winter solstice on December 22nd is the shortest. Equinoxes in March and September have equal day and night worldwide. Polar regions experience extreme patterns, 6 months of continuous daylight followed by 6 months of darkness, while the equator always has 12 hours of day and 12 hours of night with minimal seasonal changes. One of the most spectacular celestial events is a solar eclipse, when the moon blocks the Sun. But how can the small moon block the enormous Sun? The answer lies in apparent size and distance. In an activity, we can hold up our thumb to cover a friend's head from 5 meters away. Our tiny thumb can cover their entire head because it's closer to us. Similarly, the moon appears the same size as the Sun from Earth because it's much closer, even though it's physically much smaller. During a solar eclipse, the moon comes between Earth and Sun, casting its shadow on Earth. There are different types: total eclipse when the moon completely covers the Sun, partial eclipse when it only covers part, and annular eclipse when the moon appears smaller, leaving a ring of fire. It's crucial to understand eclipse safety. Never look directly at the Sun during an eclipse, as it can cause permanent eye damage or blindness. Sunglasses are not sufficient protection. Safe methods include using solar eclipse goggles, pinhole projection, or attending planetarium events. Ancient people feared eclipses and developed many superstitions, but now we understand them scientifically and can enjoy them safely. While solar eclipses occur when the moon blocks the Sun, lunar eclipses happen when Earth blocks sunlight from reaching the moon. During a lunar eclipse, Earth is between the Sun and Moon, casting its shadow on the Moon. The amazing thing about lunar eclipses is that they're safe to watch with the naked eye. During a total lunar eclipse, the Moon doesn't disappear completely but turns a dramatic dark red color, often called a blood moon. This happens because Earth's atmosphere bends some sunlight around our planet, filtering out blue light and allowing red light to reach the Moon. Lunar eclipses are more common and visible from larger areas than solar eclipses. While solar eclipses last only a few minutes and are visible from small areas, lunar eclipses can last for hours and are visible from entire hemispheres. Eclipses have great scientific importance. They help astronomers study the Sun's corona, verify calculations, and conduct various researches. India has contributed significantly to eclipse science through institutions like the Kodaikanal Solar Observatory, established in 1899, which has provided solar data for over 100 years. M.K. Venu Bapu, known as the father of modern Indian astronomy, established telescopes across India and studied eclipses worldwide. Let's review our cosmic journey through this chapter. We've learned about Earth's rotation, spinning on its axis every 24 hours, causing day and night, and making celestial objects appear to move across our sky. We've explored Earth's revolution, orbiting the Sun every 365.25 days, causing changing seasons and different night skies throughout the year. We've understood how the combination of Earth's tilt and revolution creates our climate patterns. We've discovered eclipses, both solar when the moon blocks the sun, and lunar when Earth blocks sunlight from the moon. These celestial phenomena connect to our daily lives in many ways, from timekeeping and agriculture to navigation and cultural festivals. As we look to the future, we can explore fascinating what-if scenarios. What if Earth had no tilt? We'd have no seasons. What if Earth rotated faster? We'd have shorter days. The universe offers endless possibilities for exploration. Remember to keep looking up at the sky with wonder and curiosity. There are always new cosmic mysteries waiting to be discovered.